Ever wondered what happens when a star gives up on life and collapses in on itself? Meet black holes, cosmic vacuum cleaners so powerful they can trap light itself. They're the universe's ultimate rule breakers, and they're absolutely mind-blowing. Here's the wild thing about stellar death. When a massive star runs out of fuel, it throws the mother of all tantrums. We're talking about a star at least 20 times bigger than our Sun, burning through its last bits of hydrogen like a teenager burning through their allowance. When the fuel's gone, gravity takes over. The star's core crashes inward with the force of 1,000,000 nuclear bombs, while its outer layers blast outward in a spectacular supernova. But the real magic happens at the center. The leftover core gets squeezed so incredibly tight that it breaks the rules of regular physics. That's your black hole being born, folks. Let's talk about the event horizon. It's like the universe's most extreme do not cross line. Imagine you're playing a cosmic game of chicken with a black hole. As you get closer, space and time start acting like silly putty. At the event horizon, things get truly bizarre. Light itself throws in the towel and gives up on escaping. If you cross this boundary, please don't. You'd be stretched like cosmic spaghetti, and time would do loop-de-loops that would make Einstein's head spin. The weirdest part? Someone watching from far away would see you freeze in time, like a glitchy video game character stuck at the loading screen. Ready for your brain to feel like it's doing backflips? Let's talk about how black holes turn time into their personal plaything. The closer you get to a black hole, the slower time moves. And I'm not talking about that feeling you get waiting for your coffee to brew. If you had a super strong telescope and watched your friend fall into a black hole, worst friend ever by the way, you'd see them move slower and slower until they basically freeze. But from their perspective, everything's moving at normal speed. It's the rest of the universe that's gone into fast-forward mode. Einstein called this time dilation, but I call it the universe's weirdest time management hack. It's like cosmic jet lag taken to the extreme. Let's get weird and talk about spaghettification, possibly the most metal way to die in space. Imagine you're falling feet first into a black hole. The gravity at your feet is so much stronger than at your head that you start stretching like taffy. Your body gets longer and thinner, turning you into a human noodle. The difference in gravitational pull between your head and toes becomes so extreme that you'd literally get pulled apart atom by atom. It's like the universe's most intense taffy pulling machine, except instead of delicious candy, it's, well, you. And here's the kicker. This cosmic pasta maker isn't just a fun nickname. Scientists actually call this process spaghettification, because sometimes the simplest name is the best name. You think regular black holes are impressive? Let me introduce you to their big brothers, supermassive black holes. These cosmic giants hang out in the centers of galaxies, including our own Milky Way, and they're absolute units. We're talking about objects millions or billions of times heavier than our Sun. The one at the center of our galaxy, Sagittarius A-YAM, weighs about 4 million suns, but that's actually tiny compared to some others we've found. The current record holder, a beast 66 billion times more massive than our Sun. These cosmic heavyweights don't just sit there looking pretty. They shape entire galaxies, flinging stars around like cosmic confetti and occasionally snacking on anything that gets too close. Remember when I said nothing escapes a black hole? Well, Stephen Hawking dropped a cosmic plot twist on us in 1974. These space monsters actually leak. Through some seriously weird quantum mechanics magic, black holes give off tiny amounts of radiation. It's like they're sweating, but instead of water, they're losing mass and energy. The smaller the black hole, the faster it leaks. A black hole the size of a mountain would light up like 1,000,000 nuclear bombs, while the supermassive ones are practically immortal. They leak so slowly it would take longer than the current age of the universe for them to vanish. When black holes crash into each other, they create the biggest party in the universe. These cosmic collisions release more energy in a few seconds than all the stars in the observable universe combined. The space-time fabric ripples like a pond after you throw a boulder in it, sending gravitational waves zooming across the cosmos at light speed. We actually caught one of these space quakes back in 2015. The signal made a chirp sound that had physicists jumping for joy. It's like two cosmic sumo wrestlers doing a dance-off, except their dance moves can literally bend space and time. The wild part? These collisions happen way more often than we thought. The universe is basically a giant mosh pit of black holes slamming into each other. You know that blurry orange donut photo that broke the internet in 2019? That's M87, our first ever snapshot of a black hole. Getting this photo was like trying to spot a donut on the moon from Earth. It took 8 telescopes across 4 continents, working together like a giant Earth-sized camera, plus 2 years of number crunching by some seriously caffeinated scientists. What you're seeing isn't actually the black hole. It's the hot gas swirling around it at nearly light speed, glowing like a cosmic warning sign. The dark center. That's the shadow of the point of no return, about 6.5 billion times more massive than our Sun. This photo didn't just look cool, it proved Einstein's theories were right all along. Here's a wild idea that will keep you up at night. What if microscopic black holes are zipping through space right now, maybe even passing through Earth? These aren't your typical star-death black holes. They're primordial black holes, born in the chaos of the Big Bang when the universe was younger than a TikTok trend. Scientists think the extreme pressure and density of the early universe might have squeezed tiny chunks of space-time into these mini cosmic vacuum cleaners. They could be as small as an atom but weigh as much as a mountain. Don't worry though, if they exist, they're probably too tiny to gobble up anything bigger than a few particles. Still, they might explain some of the universe's biggest mysteries, like dark matter. Let's fast forward to the ultimate endgame of our universe. Black holes are like cosmic Pac-Men, munching their way through space. Eventually, they'll merge into bigger and bigger monsters. But here's the twist. They can't keep eating forever. Thanks to Hawking radiation, these cosmic gluttons will eventually evaporate. The smaller ones go first, popping like cosmic fireworks. The big ones? They'll stick around for an impossibly long time, like 100 years. That's way longer than the current age of the universe. As they slowly fade away, they'll leave behind nothing. Just empty space and cold radiation. Kind of poetic, isn't it? The universe's biggest bullies eventually dissolve into cosmic whispers. Thanks for joining me on this mind-bending journey through the darkest corners of space. If you enjoyed getting your brain twisted by black holes, smash that like button and subscribe for more cosmic weirdness. Share this with a friend who needs their mind blown.